Hey everyone, I'm going to be talking today about a demo that I built involving baking with machine learning. My name is Sarah Robinson. I'm a developer advocate on Google Cloud focused on machine learning. You can find me on srob tweets on Twitter, and I also blog on my personal blog at sarahrobinson.dev. So let's dive right in. What I'm going to cover today is first I'll talk about how I came up with the idea for this project, how I built a very tiny data set, going to combine it all together into a fun machine learning model, and then I'm going to talk about a little baking experiment that I did at the end of this. So during this quarantine time, I have been baking a lot. These are all things that I have baked during quarantine, which when put on this slide looks like a lot, and it is. So I've been really enjoying baking. And a couple of weeks ago, I started doing my work and realized that I kind of would have more fun baking. So then I decided to see could I find a way to involve baking in the work with some of the machine learning products that I use. So this is a story of how that came to be. So when I first thought of this idea, I posted on Twitter. And what sparked this is I wanted to learn a little bit more about the science behind baking, because from a little reading that I had done, it seems like there are some high level rules that different types of baked goods follow. So I wanted to see what people thought of this. A lot of people responded, well, maybe you could just read a book on this or a blog post, which is good advice. But what I was really interested in doing is seeing if I could train a machine learning model to do this for me. So what I wanted to train the machine learning model on was different ingredient amounts in a recipe to see if based on those ratios, it could predict what the recipe was for. So I did a little reading and discovered that yes, there is indeed some high level patterns here, which made me think that it might be a good fit for machine learning. So here we can see some common ingredient ratios. And basically, if you understand these ratios well enough, folks say that you should be able to start creating your own recipes. So I thought it'd be pretty cool if we could train a machine learning model on these ratios. But thinking about it first, I was wondering, do we actually need machine learning for this? So if the bread ratio is simply 5 to 3 approximately for flour to water, could we just write a simple if statement like this? Well, that would work, but then it might get a little tricky to account for different edge cases. So for example, some bread recipes have eggs in them. So if it has egg, then you'll need to check what the flour to egg ratio is. And some breads have yeast, so we need to account for that. So you could see how this code could get pretty long, especially as we would want to add more types of things that we want to classify. And other edge cases could be a bread that doesn't have yeast, a cake that has no eggs, a sugar-free cookie. The list could go on and on. So my conclusion from this short analysis was this could be a good fit for machine learning. So I wanted to find out. First, before I go any further, what is the point of all this? You're probably not going to go build your own baking prediction model after watching this talk. First of all, it's fun. We could all use something fun right now. It's also a good demonstration of when it's a good fit to use machine learning over traditional programming, which is rule-based, as we just saw. I'm going to show you an end-to-end solution from training your model to deploying it on Google Cloud. And something that I thought would be interesting for this is, so you might be thinking it's kind of silly when you're entering ingredients for a recipe, you already know what recipe that is. So what's the point of having a model predict something you already know? Well, think about it this way. You could also enter inputs of maybe just things that are lying around your pantry to see what you could bake with those things. So the whole point of machine learning is to get predictions on unknown inputs. So while yes, we could use the model to see how it performs on recipes that we already have, we could also use it to maybe see what's possible. So we might be doing that at the end. So first step to training a model is to get some training data. And what I wanted to do was train a model on basic ingredients that are in a lot of baked goods. I did some quick searching and I couldn't find a data set that existed like I wanted. So I decided to create my own. And there's no shortage of recipes on the internet. So I just started making a data set in a spreadsheet, manually entering ingredient amounts from different recipes that I found. And this is what it looks like. This is a screenshot from my data set. I made some assumptions about as I was collecting the data just to keep things simple. I'm only considering 12 ingredients, and these are the features to my model. So the features are these 12 ingredient amounts. The label is, what is this? And for this first iteration of my model, I kept it to just 3 labels. So we're predicting whether it's a bread, a cake, or a cookie. More on that later. The other assumptions I made were that all flours are the same. So there was a few recipes I encountered that use different types of flours, like whole wheat flour, all-purpose. I just combined the amounts of those into one feature as flour. Same with sugar. So we have granulated sugar, powdered sugar, brown sugar. I just combined all of those again into one sugar amount. So the resulting data set has 99 recipes, 33 breads, 33 cakes, and 33 cookies. As I was collecting the data, I tried to get a variety of each type of recipe. So, breads with sourdough starter, breads with yeast, breads without either, different types of cakes and cookies. You get the idea. So machine learning models they need numerical inputs. And so for data like images and text, this often requires a lot of pre-processing. So you need to convert those images and text into a numerical format that your model can understand. So going into this, I thought, okay, well, since all of the ingredient amounts are numerical, maybe I can feed that directly into my model. But it turns out there was some pre-processing that I still needed to do. First problem was that I had a mix of different types of units. So I had cups, teaspoons, and then just eggs. So I needed to account for that. I also needed to account for the fact that all recipes make different amounts. So maybe I have one recipe that makes like 4 loaves of bread and another recipe that only makes 6 cupcakes. I don't want it to give more weight to a recipe that makes more of a certain type of baked good. So I also need to scale my inputs, which is a common practice in machine learning, especially if you have a lot of different numerical features. And let's say some of them range from 0 to 1 that are floats, and some maybe you're collecting data on revenue or sales. That's going to be a really big number, and that'll make it difficult for your model to converge if all these numbers are kind of all over the place. So you want to scale them. So that's what I did. So let's pretend that this is an input recipe. This isn't a recipe for anything, but we'll just use it to show you how I did the data pre-processing. So since most of my model's inputs were in cups anyway, I just converted teaspoons and eggs to cups. So for teaspoons, that was pretty easy. Just looked up exactly how many teaspoons in 1 cup. For egg, it's a little trickier. I just did some searching and landed on 1 egg is 0.2 cups. Not perfect, but it works. So first converted everything to cups, so we're all working in the same units. And then what I did was to feed it into my model, I wanted each ingredient amount to be the percentage of the recipe that it makes up. So I just added up all of these numbers together. So 3.2 for this recipe, divided each amount by the total to get the percentage of the total recipe. So we land on these percentages, which we then feed into our model. So here's one row of the data, the raw inputs, the ingredient amounts in cups, teaspoons, and eggs, and then we convert it to ratios. So we've got our data ready. Now we need to think about what tools we're going to use to build this. I work on Google Cloud, so I'm going to use Google Cloud to solve this. So this is just an overview of the different machine learning tools that are available on Google Cloud. So this pyramid is organized by levels of abstraction. Now the products on the bottom half are targeted more towards data scientists and machine learning engineers, folks that have a little bit more ML experience. And as we move towards the top, these tools are targeted more towards application developers, data analysts, folks that want to use machine learning but may not have as much of a ML background. So to solve this, I'm going to use an open source machine learning framework, TensorFlow, to build my model. And I'm going to deploy my model using a service called AI Platform Prediction. Now what that lets you do is take any model that you've trained. Once you've trained it, you deploy that to AI Platform Prediction, and then you can access that model behind an API. So I'm going to talk about that a little bit more later on. Someone mentioned that I also could have used AutoML tables to solve this, which is absolutely true. I just chose TensorFlow mostly just because I wanted to do this in TensorFlow. So the TensorFlow model that I built looks like this. I'm not going to go into the details here, but basically the TensorFlow sequential model API lets you define your model as a stack of layers. So here it's pretty straightforward to see, to visualize and code all of the different layers of my model. Now let's look at what the input and output to our model is going to be. So the input to our model is this 12-element array, and this is the pre-processed array. So these are the ingredient amounts expressed as ratios, which we just saw in the previous slide how we transform those. Then our model has a series of hidden layers. These are called hidden layers because the output of those layers isn't really meaningful to us. What we care about is the output of the final layer. But the transformations that happen throughout the hidden layers help the model learn. So our model's output is what's called a softmax layer. A softmax probability means that we want to predict the probability that we want to So the output of our model is what's called a softmax array. And what this is going to tell us is the probability that this particular input belongs to each of our three possible classes, bread, cake, and cookies. So what we get is an array of 3 elements because we have 3 different possible label classes. And this array is always going to add up to 1. And these are associated with probability. So for this particular input, our model thinks there's a 97% chance this is bread, 2% chance this is cake. So you get the idea. And the labels are in this order, as you can see with the emojis. So this is what our model looks like. So I trained the model. The model trained really fast, just in a matter of seconds. So I didn't need to use the cloud to train it. I trained it just in a Colab notebook, which I'll show you in a moment. So I wanted to evaluate the model. And to evaluate the model, I tested it on a couple of recipes. One that I'll talk about, which someone pointed me to on Twitter, is a recipe called Jaffa cake. And the reason that I thought it'd be fun to test this on the model, this is a British dessert. And there's been some controversy over whether this is a cake or a cookie, biscuit as they call many types of cookies over there. The reason this is controversial is because chocolate covered cakes are taxed differently than chocolate covered cookies. So this actually went to court many years ago. The court ruled that it is indeed a cake. So I wanted to see what my model would predict. So my model predicted 88% chance of cake. So I was pretty excited about that. If you're interested in the recipe, I've linked the Great British Bake Off version here. That's also a great episode of British Bake Off. Highly recommend watching it. So I evaluated my model, but right now it's not deployed anywhere. I just have it running in a notebook, so I'm the only one that can access it. I'd like to deploy my model so more people can access it. So I'm going to use AI Platform Prediction. For that, I talked about it briefly before. So what it lets you do is deploy your models. You deploy them either using the Google Cloud CLI, or you can do it directly in the AI Platform UI. So you can make your predictions using the AI Platform Prediction API. It supports auto scaling and manual scaling. So auto scaling just means that you won't be charged when nobody's making a prediction request on your model. It'll scale all the way down to 0. If you'd like to set up manual scaling, you absolutely can. And it also supports online or batch prediction. We're going to use online prediction since eventually we want some sort of web interface where people can make requests to our model and get the results back in near real time. Batch prediction is, let's say you have like hundreds or thousands of test instances that you want to run on your model. You can create a batch prediction job and those will run in the background. So to deploy our model to AI Platform Prediction, I use gcloud to do it. All I need to do is point it at the location of my saved model assets. So once I train my TensorFlow model, I just call model.save. That saves it in the TensorFlow saved model format. So I just copied those assets to a Google Cloud Storage bucket, which I'm pointing to here, telling AI Platform which runtime version I'm using, which framework, and which Python version. And once my model is deployed, I can see it here. So I'm going to show a demo real quick of querying my model. I'm going to go to Colab to do that. So this is Colab. It's a Python notebook that's available directly in the browser, and it's totally free to use. You can create your own if you go to this URL at the end. So I'm going to show you a snippet of this Colab where we're going to be pinging the AI platform model that I deployed, which we can see in the AI platform console here. I've deployed 2 versions of it. So I've hard-coded an example of bread in here, and I've already scaled the inputs to percentages of the total recipe. So we're going to write that to a file, and we're going to send that file to our AI platform model using gcloud. So we can see here that we got our softmax response returned from our model, which is great. And if we remember from the slide, we'll know that this index, the first index, corresponds with bread. So our model is 99.9% confident that this is bread, which indeed it is. So we've called our model, it worked. But the problem here is that this input and output format isn't very user-friendly. So I don't know when looking at this array, which corresponds with which ingredient, what amount in cups or teaspoons that corresponds with. And I only know what each of these softmax indices correspond with because I built the model. So we want to maybe find a way to send our model the information maybe in an object with the key value pairs corresponding with the name of each ingredient. And we want the output a little bit easier to read so we don't have to memorize which index corresponds with each label. So I'm going to go back to the slides. As we saw, scaling inputs on the client is not great. This is common practice in machine learning. So you often, when you're training a model, you want to scale all of your numerical inputs before you send them to your model for training. So that's something we as data scientists should be concerned with. But our model end users shouldn't have to worry about this at all. It wouldn't be very nice if I built a web app and made people convert all their ingredients to cups and then scale them as ingredient ratios. That just wouldn't be very fun. So I wanted to see if there was a way we could handle this on the server. And Cloud Functions turned out to be a great fit for this. So if you don't know what Cloud Functions are, they let you write functions that respond to events in your cloud environment. You can choose from a number of different events. So the one that I'm going to use is an HTTP function. So this will respond when I send a post request to my HTTP endpoint. You can also write functions that respond to when data is added in Firestore, lots of other things. It's entirely serverless, and you have your choice of runtimes. I'm going to use Python just because that's what I wrote my model in and what I'm familiar with right now. Shout out to my teammate Brett. His Twitter handle is on the slide. He helped me get the function working. So at a high level, what do I want my function to do? I want it to take the data in a more user-friendly format. So I chose an object here and scale that data, send it to my AI platform model, and then parse the response, return it in a format that's a little bit easier to understand. So this is roughly what my function code looks like. You don't have to look at it all. The important bit here is the response format. So I'm sending the highest prediction. So I'm just going to return the top item that my model predicted, how confident it was in that prediction, and the emoji, because I like emojis a lot if you can't tell already. So let's see a demo in Colab of calling our model now via a cloud function. So I've hard-coded some more test examples here. The first one is the Jaffa cake, the same one that I showed you on the slide, and second one is banana bread. I chose to try banana bread with my model because I've often wondered why it's called banana bread, since it's always seemed more like a cake to me. So we're going to send these to our model, and notice that I've written my function in a way that it accepts an object of ingredient amounts, ingredient name, and ingredient amount. So we'll send this to our function and see the response. And we can't see the emoji rendered here, but that's okay for now. So Jaffa cake, as I mentioned before, it's 88% confident that this is a cake. And banana bread, on the other hand, it's 51% confident that it's a cookie, which is pretty far off. But when I thought about this, I realized that if you've ever made banana bread, you know that bananas make up a bulk of the batter. And I don't have a banana feature in my model. So this recipe isn't really being accurately represented by the other ingredients. So I know that in some recipes you can substitute banana for egg. So let's see what happens if I add, for example, one more egg to the recipe and a little bit of oil. Bananas are kind of oily. And now let's see what happens. Okay, so now it thinks that this is 77% confident that it's cake, which is closer, in my opinion, to what banana bread actually is. So we see here how we're calling our model via the function now. This is the Cloud Functions UI. What's great here is that you can edit the source code for your function right in the browser and then redeploy the function. So that's mainly the environment I use to write and update my function. So now that we know how our function works, let's go back to the slides. And I wanted to put it all together in a way that we had a nice web app to query the model. So the idea here is that we'd build a web app, pretty simple app. The web app would gather the ingredient amounts and send that to our cloud function, which would then send it to our model, and we would return the prediction on our web app and visualize it for the user. I use Firebase Hosting to deploy my web app. If you're not familiar with Firebase Hosting, it lets you deploy web and mobile apps to a global CDN. You just use the Firebase CLI. It's really easy to deploy. You get SSL by default, and it supports a number of different extra things. So I put it all together, and my front end skills are not great. So it's literally a single HTML page. I recorded a GIF of it and I tweeted it. I was kind of surprised at how many people liked this, and I realized that I guess people are interested in baking right now, or just fun demos. Anyway, I tweeted this, and my colleague David, who I used to work with on Firebase, saw my tweet, and he said, "Hey, could I help you build a nicer front end for this?" And I was like, "Wow, sure, that would be great." So he did. It turned into this, which looks awesome, and we're going to try it out. Before we try it out, a quick note. You might have seen this saying before. I didn't invent it. Machine learning, just a reminder, is garbage in, garbage out. So your model is only as good as the data that you train it on. So my model only knows how to classify these ingredient amounts into 3 different recipes: bread, cake, and cookies, because that's all I trained it on. So you can think of it kind of like a baby that only knows 3 words. Not a perfect example, but it kind of works. So if I send something ridiculous to my model for prediction, or even just a different recipe that falls outside of one of those categories, maybe like a croissant or something, it's going to try to classify that into the only 3 categories it knows. And it might even do so with high confidence. So if I enter croissant ingredients, there's a chance it'll classify it maybe as a cookie with 90% confidence. It really is, it's only as good as the data it was trained on. And I also didn't train it on like a none of the above category. So let's say I enter, for example, like 10,000 eggs, and that's it. My model's still going to try to categorize it as something. So just a quick note before you play with this. Let's go check it out. So here's the final UI. Looks really cool in my opinion. Thank you, David. So let's just enter some random stuff in here. 1 cup of flour, 1 cup of sugar, and 1 egg. Let's see what it says. Thinks it's cake with 74% confidence. Sounds somewhat reasonable. And you can also pre-fill with recipes that fall into these categories, or just generate random combinations of ingredients. So I encourage you all to go check it out, whatayoubaking.com, and have some fun with that. So I'm going to go back to the slides once again. So once I had built and trained my model, I wanted to see if I could use it to create something weird. So I kept playing with different combinations of ingredients to see if I could come up with something that caused my model to predict 50% cake, 50% cookie. And I did. This combination of ingredient amounts happened to do it. So should I make this? Obviously, I made this because I was so curious what would happen. So here's pictures of every step of my process. And I did stick exactly to the ingredient amounts that were shown, that my model predicted, 50-50. I did make a couple of tweaks to the actual ingredients. So I mentioned before that I made an assumption that all sugars were the same when fed to my model. So I decided just why not? The input was half a cup of sugar, so I decided to just split that into white sugar and brown sugar and see what happened. I also added vanilla extract and chocolate chips. Those weren't my features, but never hurts to add those to a recipe. This was the result, and it actually turned out quite good. Um, the best way I can describe it is that it tastes like a hybrid cake slash cookie. I froze a lot of the original batch because I don't have many people to share my baking with right now. I just defrosted some for this presentation. If you want to see what it looks like, I'm actually going to hold it up to the camera. Now it's been frozen for a few weeks, so it's not in tip-top condition, but it looks like this. If I break it and hold it up, you can kind of see the texture is, oops, I got it on my keyboard now. It's crumbly like a cookie, but also has cake-like qualities. So I was pretty pleased with the result. The recipe I've posted on my blog. One other addition or change that I made to the recipe, my parents have a friend who's a professional chef, and she actually tried the recipe. She really enjoyed it. Initially, I used canola oil. She said to use extra virgin olive oil, and I haven't tried it yet, but surprisingly, it doesn't transfer the flavor of the olive to the end result. So use extra virgin olive oil if you make it. I did update the recipe with her modification. Some next steps, things I'd like to add to this. I've been working a lot recently on machine learning explainability. What explainability does is it helps you understand why your model made a particular prediction. So it can help us answer the question, why did the model predict, cake or cookie? Because right now we can get a response from our model like, okay, it's 99% confident that this is bread. We don't know why it made that prediction. And understanding that can really help us verify that the model is working correctly. So I deployed a test version of this model with explainability enabled. I haven't yet added it to the web app, but this is what explainability tells us. So it gives us what's called feature attributions. And this tells us for each feature in our model, in this case, for each ingredient, how much did that ingredient contribute to our model's prediction? So for this particular example that I'm showing the JSON for here, we can see our model predicted cake for this one. And if we want to understand why, it looks like eggs was the most important feature, followed by baking powder, and then butter. So it's really interesting, helps us understand how our model is working under the hood. This product is available. You can use it through AI platform prediction when you deploy TensorFlow models. I've got lots of resources on it. I'll share some at the end. And if you're looking for more, just search for explainable AI or reach out to me on Twitter and I can send you some samples. So other things I'd like to add, it'd be awesome to add more training data and labels to this model. I'd also like to try it on auto melt tables. Might just be interesting to do some benchmarking. I could also try comparisons maybe in scikit-learn, XGBoost, simpler models. I'm working on open sourcing the code along with the code for the front end web app. When I do that, it would be great if people submitted pull requests with more data. And I'm open to other ideas. If you found this interesting, fun, let me know what I could add. Some links if you want to learn more. I'll just leave this up for a moment. I have the code for my cloud function is available in a gist. As I mentioned, still working on getting the code for building the model, deploying it. But I will publish that on GitHub soon. And that's all. Thanks for watching. Let me know what you think. Reach out on Twitter. I'm srobtweets. Thanks, everyone.